Hello everyone, today I will explain briefly about the group 14 elements. So first let's see what are those group 14 elements. So carbon, silicon, germanium, tin, lead and ferrovium are the members of group 14. Now let's briefly see about these elements. So first let's talk about carbon. So carbon is the 17th most abundant element by mass in the Earth's crust. In elemental state, it is available as coal, graphite, and diamond. However, in combined state, it is present as metal carbonates, hydrocarbons, and carbon dioxide gas in air, which is 0.03%. It is an essential constituent of all living organisms. It also gives an astonishing array of materials ranging from living tissues to drugs and plastics. Naturally occurring carbon contains two stable isotopes, carbon-12 and carbon-13. In addition to these, a third isotope, carbon-14, is also present. But this kind of isotope is like rare in nature. Also, organic chemistry is incomplete without carbon. Carbon is the like base of the organic chemistry. Let's see about silicon. Silicon is the second most abundant element on Earth's crust, which is 27.7% by mass and is present in nature in the form of silica and silicates. Silicon is a very important component of ceramics, glass, and cement. Now let's talk about germanium. It only exists in traces, and tin occurs mainly as cassiterite, which is tin dioxide, and lead occurs as galena, which is lead sulfide. Nyorovium is synthetically prepared radioactive element. Let's see some extra facts about these elements. Ultra-pure form of germanium and silicon are used to make transistors and semiconductor devices. These are used mainly like in computers, televisions, and fridge and other electronic devices. Then symbol of lyrovium is Fl. It has atomic number 114 and its atomic mass is 289 grams per mole, and electronic configuration is followed by radon and F5F14 6D10 7s2 7p2. It has been prepared only in small amounts. Its half-life is short and its chemistry has not yet been established. Also, oxygen is the most abundant element on the Earth's crust. Now let's talk about the electronic configuration. The valence shell electronic configuration of these elements is ns2np2. The inner core of the electronic configuration of elements in this group differs. This is mainly due to the fact because they have d and f orbitals also. Let's talk about the covalent radius. There is a considerable increase in covalent radius from carbon to silicon. Thereafter, from silicon to lead, a small increase in radius is observed. This is due to the presence of completely filled d and f orbitals in heavier members. The main reason is as we move down the group, new shells are added, and so the nucleus can't pull the electrons. Thus, the size increases down the group. Also, the extent of shielding is there, which is mainly seen in the s orbital, followed by p, d, and in the end f, which has the least extent of shielding. So, heavy metals like silicon and lead have filled inner d and f orbitals, and due to poor shielding effect of inner subshell, nucleus has tight hold on valence shell. So there is marginal increase in their atomic size. So silicon and lead are mostly similar in their size. Let's talk about ionization enthalpy. The first ionization enthalpy of group 14 members is higher than the corresponding members of group 13. The influence of inner core electrons is visible here, those d and f orbitals. The small decrease in ionization enthalpy from silicon to germanium to tin, and slight increase in ionization enthalpy from tin to lead is a consequence of poor shielding effect of intervening d and f orbitals and increase in size of the atom. In general, the ionization enthalpy decreases down the group. We know the ionization enthalpy is the enthalpy required to remove one electron from a compound or an element. Now, electronegativity. Due to small size, the elements of this group are slightly more electronegative than the group 13 elements. The electronegativity value for elements from silicon to lead are almost the same. That's generally because of the similarity in their size. This is a table which like you can refer if you want. It is about the atomic and physical properties of group 14 elements. And thank you. And I hope that you understood the points I explained over here.